This video is going to cover problems 9 through 11 on the 4.0 practice sheet. The original problem on number 9 is 54x to the 7th y to the 9th over 8x times z to the 5th, all of that raised to the 1/3 power. And so the first thing that we're going to do on number 9 is take everything inside the parentheses that were given and raise it to the 1/3 power. And since the power is outside of parentheses, we're going to multiply it by all of the existing exponents. So we're going to have to do 7 times 1 divided by 3, and then 9 times 1 divided by 3. And then also we're going to have to take x to the 1/3. We're going to have to take z to the 5th to the 1/3. And the last thing that we're going to have to do is also distribute that exponent to the actual base numbers, so that everything inside gets to the power of 1/3. So once we distribute the 1/3, here's what we have on the top: 51 to the 1/3 times x to the 7/3 times y to the 9/3, and then we have 8 to the 1/3, x to the 1/3, and z to the 5/3. And so just some simplification. We're going to do this would be the cubed root of 54. And this would be x to the 7/3, and on the bottom there's 1/3, so 7/3 minus 1/3 would be x to the 6/3, and there's no other y's to cancel, and 9 divided by 3 is 3, so that would be y to the 3rd. On the bottom, that's going to be the cubed root of 8, and then we got rid of the x to the 1/3 when we canceled this 7 minus 1 when we got 6, so it's no longer on the bottom. And then we do have z to the 5/3 on the bottom. So the next thing I'm going to do is break down the cubed root of 54. So the cubed root of 54 breaks down into the perfect cube of 27, and it goes in 2 times. And then the cubed root of 8 is 2. So we've got all the numbery types of things taken care of. On top, we've got x to the 6 divided by 3, which is just x squared, and then y cubed. On the bottom still, we have z to the 5/3, so we'll deal with that in just a second. This translates into the cubed root of 27 is 3, and then times the cubed root of 2. We've got x to the 2nd, y to the 3rd on top. We still have a big 2 on bottom, and z to the 5/3. So the next thing we need to do is rationalize the denominator. This is not okay to be on the bottom of a fraction for your 4.0 objective stuff. So we need to make that fraction a whole number, and the next number that 3 goes into is 6. So we need to multiply everything by z to the 1/3 on the top, and then z to the 1/3 on the bottom. So that now on the bottom, we just have 2z, and then that would be 6 divided by 3, which is just 2z to the 2nd on the bottom. And then on top, we have z to the 1/3, which is the same thing as the cubed root of z. And we also already have the cubed root of 2 right here. So these two things are both under the cube root. So for our final answer, we're going to have 3 times the cubed root of 2 times z, since both of those are to the 1/3 power. And values that we have not under the cube root are x squared and y cubed. So this would be the final answer for this 4.0 problem. So number 10, the original problem is 3 divided by the 8th root of x cubed. And it's easier sometimes to rewrite these in exponential form, especially when we're dealing with fractions. So I'm going to go ahead and do that. That's 3 divided by x to the 3/8. And so really the goal here is to rationalize the denominator. And so we're trying to figure out how can we get this fraction to be a whole number? What do we need to multiply by so that we can add exponents to get that to be a whole number? And the next number from 3 to 8, obviously 8 is going to be what we have to get it to go into. And so to get to 8, we need to add 5. So we need to multiply by x to the 5/8 over x to the 5/8. And so multiplying left and right, we've got 3 times x to the 5/8 over, and so 3 plus 5 would be x to the 8 over 8, which is just the same thing as over x. That was the whole point of rationalizing the denominator. And so writing our answer, final answer, since it was given to us in radical form, I'm going to leave it in radical form. And so we still have the big 3, and we're still talking about the 8th root of x, and it is to the 5th power. So your final answer for number 10 should look like this. So the original problem here is 81 to the 3/5 times 81 to the 1/3 divided by 3 to the 1/4. So the first thing we're going to do is change these 81s to the base of 3. And 3 to the power of 4 gives us 81. And so we're just changing the 81 to 3 to the 4th. So the 3 to the 5th, 3/5 power is still there. And again, 3 to the 4th to the 1/3 is still there. And it's still all divided by 3 to the 1/4. And so now we're dealing with exponents outside of parentheses. So we're going to multiply these together. So 4 times 3/5 is going to be 3 to the 12/5 times 3 to the 4/3, still over 3 to the 1/4. Multiplying bases, we're going to add exponents, so we're adding 12 to the 5th and 4/3. So that's 3 to the 12/5 plus 4/3, because the bases are being multiplied, still divided by 3 to the 1/4. This 12/5 plus 4/3 gives us 3 to the 56 fifteenths, still over 3 to the 1/4. And now we have the same base that's being divided, so we're going to subtract. This will be, I need some more room here. This will be 3 to the 56 fifteenths minus 1/4. Since it's divided, we're subtracting exponents, which is, if you do that in your calculator, you will get 3 to the 209 divided by 60th power. And so this is kind of long and gets a little ugly, but as long as you're using the exponent rules in your calculator to help you with the fractions, it's not that bad. We're just seeing how well you can use the properties of exponents.